right, let's look at some more probability. On this one, it says, find the probability of being dealt each of the following hands in 5-card poker. Use a calculator to get your your answer to 8 decimal places. So they gave me a table over here, okay? And they want the probability of getting a full house. So if you go down and you look at full house, the chances of a favorable outcome are 3,744. So that goes on top. Now remember, your total options goes on bottom. Well, the total's down here, 2,598,960. So that goes on bottom. If you reduce that, you get 6 over 4,165. And they typically write it as a decimal. If you change that to a decimal, it is 0.00144058. Now, in this case, that means your chances of getting a full house are less than 1% when you move that decimal twice, okay? You end up with less than 1%. Let's look at a royal flush. So for this one, if you look at the chart, the number of favorable outcomes, how many times did this happen out of, 2.5 million? 4 times, okay? So you put 4 on top. You put the grand total on bottom. That reduces to 1 over 649,740. And when you make that a decimal, it is way less than 1%. 0.00000154. So it's not very likely at all. Let's look at another one. Example 5 says, according to Pocket World in Figures, the 2009 edition, okay, it says the population at the end of 2006 included 148.2 million males, 152.8 million females. If a person were selected randomly from the population in that year, what's the probability it would be a male? So we're looking for male here, okay? So remember, you do the number of favorable outcomes. So you want to do how many were male on top. So if you look at my fraction down there, I do have 148.2 on top. That's the number of males. Now you need the total on bottom. So I had to take and add these two together, the males and the females. Total population was 301 million. So that goes on bottom. That reduces to 741 over 1505. And when you make that a decimal, you get 0.4924. Now think about it, you guys, it makes sense. These numbers are close, okay? Males is a little less, so it's going to be a little less than 50%. If you were to move this decimal twice, you'd have 49.24%, so it does make sense. Let's look at one more that talks about the law of large numbers. So here's what happens if we flip a coin 35 times. Now we know in our heads that the probability should be 1/2 for heads, 1/2 for tails. But when you start out, like the first 5 tosses, 3/5 of them were heads. The next 5, 3/5 were tails. So we're about half and half. Then if you look at the next 5, 3/5 were tails. The next 5, 4/5 were heads. So what happens is you end up with this graph that goes up and down and up and down. But the more you do it, which is why it says large numbers, the more you do it, the closer and closer and closer it gets to 1/2. Your decimals get so close to 1/2 that you end up with the probability of 1/2. So you just have to do it several times for it to even out to what we expect to happen.